Okay, so we're continuing with geometric series. Okay, so what's a geometric series? Okay. Okay, so in a geometric series, okay, the terms are defined by a common ratio. So let me pick an example here. Let's pick the example. The example is 1 plus 2 plus 4 plus 8, and so on. And we can see that here we are doubling the terms every single time. 1 goes to 2, 2 goes to 4, 4 goes to 8, and so on. Okay, so the situation is that we will always have a common ratio. Okay, what does this look like? Okay, this looks like first term, okay, is a. Then I have a times or. Okay, then I have a times or squared. Okay, 1 times 2, 1 times 2 squared. Okay, multiplying by the or every single time. Then a plus or cubed, etc. Okay, so that's the form of the sum. Okay, so the nth term is given by, I would have an, the nth term, okay, is the original term a, the first term, by or to the n minus 1. Okay, first term has no or to the 0, or to the 1, or to the 2 that's in the third position, and so on. Okay, so that's my general term. Okay, now how do I work out the formula for the partial sums? Okay, what about Sn? Okay, well, I'll write down the formula first and then I'll prove it. Okay, it is as follows. I take a, have 1 minus or to the n, and I divide that by 1 minus or. And this is a little bit hard to see, but let's have a look at it. Okay, let's see why. Okay, well, Sn, the sum to the nth term, what does that look like? Okay, that is a plus a to the a times or plus a or squared plus all the way up to plus a or n minus 1. Okay, that's what I have. And that doesn't look anything like that. Okay, and you might say, well, why not just use this? Okay, if this is Sn, why not just keep this? And the answer is this could have 100 million terms. Okay, Sn could be, the sum to the 100th millionth term. But this is much simpler and much more straightforward to use when I have a lot of values. This is okay if I have 2 or 3 terms, but if I have 50 terms, it's really not pleasant to use. So let's take this and let's multiply this by or. And what do I get? Well, then I have a or plus a or squared plus all the way up to a or to the n. All I'm doing is multiplying every single term here by an or. So the power of or goes up 1. Okay, now let's take Sn and take away or times Sn. Okay, well then what do I have? That's this term, a plus a or plus a or squared plus all the way up to a or n minus 1. Okay. And I subtract away a or plus a or squared plus all the way up to a or to the n. And we can see that there's matching that happens here. Okay. So for example, this a won't cancel with anything, but this a or here, plus a or, will cancel with this minus a times or. This a or squared will cancel with this plus a or squared. And this continues all the way up to everything except these two outside terms. So I end up with Sn minus or times Sn is going to be equal to a minus a times or to the, Sn minus or times Sn is equal to a minus a times or to the n. Okay, and now we can see that I have some common terms here. This is 1 minus or by Sn, and that's equal to a by 1 minus or to the n. Okay, and now all I do is I bring this 1 minus or across to the other side, and I have Sn is a times 1 minus or to the n over 1 minus or, like that. And that's my formula. Okay. So it's a very easy proof. I wouldn't ask you the proof, but I want you to know how where it comes from and how it works. Okay, so now let's do an example of working with a geometric series. Okay. So we have a geometric series, geometric progression, and we're told that the fifth term, A5, is 162. Okay? We're told that the eighth term, A8, is equal to 4374. And you might think, hey, that looks enormously large. But it's not really. Okay? So what do I have here? I have that 162 is equal to what? This is equal to a times, and since it's the fifth term, the power of or here needs to be 4. Now, 4,374 has to be a times or, and since it's the eighth term, it's 7. Okay, so what do I have then? Well then, 4374, if I divide that by 162, that's going to give me a or to the 7 divided by a or to the 4. The a cancels with the a, and I have or to the 7 on top, I have or to the 4 on bottom, that leaves me or to the 3. Just working with the indices is appropriate. Okay, and let's see what this is. Okay, well, this we can do on a calculator. Okay, so 4374, divide that by 162, and we see it goes in 27 times. So that means that 27 is equal to or cubed, and that would imply that or has to be equal to 3. Okay, so I've worked out what or is. Or is 3. Now I can work out a based on either of these. I now know that 162 is a times or to the 4, which is going to be a times 3 to the 4, which is a times, and 3 to the 4 is 81. Okay, you can check there on the calculator. Okay, 3 to the 4 is 81. Which means that a must be 162 divided by 81, which is of course 2. Okay, so I've worked out the situation here, and I can do basically anything I want with it from that stage. Okay, I can work out whatever whatever the terms are to whatever number. I can work out what the sums are because I have the formulas for those. Okay, so there's an example here. This is question 4 from 2013. Okay, we have that the fourth term of a geometric progression is 1 over 10. Okay, and we have that the seventh term is 1 over 270. So fractions, but it's okay. Okay, and it says here the expression for the general term un is what we're looking for, and or you could call that an, and we want the value of the 10th term. Okay, so this is fairly simple and fairly straightforward. Remember, 1/10 needs to be equal to the first term, okay, and since it's the fourth term, that needs to be or cubed. Okay, also 1 over 270 has to be equal to a times, and since it's the seventh term, it's or to the 6. Okay, so now 1 divided by 270 divided by 1/10, okay, has to be equal to a or to the 6 divided by a or cubed, and that gives me or cubed exactly as before. Okay, and now again we can do this on the calculator. It's actually a pretty simple and straightforward one because dividing by 1/10 is the same as multiplying by 10. So I would find that 1 over 27 is the same thing as or cubed. So then I find a cubic root. Okay, and the cubic root is 1/3. So I've worked out what the or is there, okay, and now I need to work out the a, okay, but that's really not so bad, is it? Right, why? Because I know that 1/10 needs to be equal to a times, and then I have or cubed, which is equal to, sorry here, okay, a times 1/3 cubed, and of course 1/3 cubed is just this 1 over 27, okay, so that's equal to a times 1 over 27. So now a has to be equal to, and it's 1/10, and I'm going to divide it by this 1 over 27, okay. Bringing across the multiplier to the other side, and this is just 27 over 10. Turn the divisor upside down and multiply, okay. So I have everything I need here. Okay, so what's the general term? The general term is that an is equal to the a by or to the n minus 1. Okay, what's that going to be equal to? The a was 27 over 10. Okay, the or was 1/3. And that gets multiplied to the power n minus 1. Okay, and that's my general term. It says here, find the general term when n is 10. It's very simple. All I'm going to do is put 10 into 10 in place of the n. and I have 27 over 10, and I have 1/3. 10 minus 1 is 9. Okay, and if you put that into a calculator, because that's not something I expect people to be able to do in their heads, you end up with 7,290. Okay, so that's my situation there. Now it says find the sum to the 7th term. So find S7. Well, what's S7? Well, remember that Sn, the formula for Sn, was equal to, let's rewind back a little bit here, it was this formula here. It was A 1 minus or to the n, and we divide that by 1 minus or. Okay, so what do I end up with? Okay, so S7 has to be equal to A was 27 over 10. Okay, I have 1 minus or was 1/3. The 1/3 was being raised to the power 7. Okay, and then on the bottom I have 1 minus 1/3. Okay, and again, something you would put into a calculator, not something you would do the long way. Okay, but it's, you know, it's fairly simple and fairly straightforward to do if you know your fractions. Okay, so what do I have? I have S7 is going to be equal to, leave that 27 over 10 there. That's going to multiply on my calculator here, 1 minus fraction, we'll put that into a 1/3, raise that to the power 7, okay, here. Okay, so power 7 goes in, and we can see that I have 2186 over 2187. And then I have to divide that by 2/3. So I have 2186 is going to get multiplied by 27 over 10. That's my numerator. Okay. And then I'm going to divide it by 2/3, which is my denominator. And I have my answer there. It's 1093 over 270. Okay. And if I 4 point something, okay, if we were to write it in decimal form, okay. There's kind of a natural break in the flow of the content there, so I think I'll stop this video there, and then we'll continue in the next video again with some notes on infinite series. Actually, let's not, okay, because this is no, let's do it. Let's do it in the next video instead. Okay, we'll continue in the next video.